Alrighty, 4.2 is our second inequalities lesson, and this is for special occasions, special inequalities that have to do with ands. So we would do it exactly like we did the regular ands. We solve both halves of the inequality. We sketch them both on the number line. If they don't, this is when they don't point towards each other. So they don't point towards each other, but you know they are and inequalities, either because they are separated by the word and, or they have less than signs of some kind separating the inequalities. If they don't point towards each other and they do point away from each other, you call this a no solution. So when you graph them on a number line, and you have one that goes one direction and the other one that goes the other direction, those are away from each other, so that would be considered a no solution. Or you have a second option. If they point in the same direction, they point in the same direction after you solve them, you pick the region where they overlap. Now, for example, you're graphing it. That's a really straight line. And you've got one that graphs in this direction. And you've got one that graphs back here also in the same direction. The solution is this portion right here where they intersect and they both end up going in that direction. So whatever that number is the region where they overlap. So here we go. We're going to have some pretty strange and inequalities today. Pretty strange ones. Now keep in mind, when you do the worksheet, they're not all going to be special cases. Some of them are just going to be normal. Number one is so simple, I think we can solve it all together. So we'll just put a line underneath the inequality signs. The only thing we need to do is get rid of the 6 on all sides by subtracting 6. We're left with n in the middle. On one side, n is less than or equal to -1 minus 6 more is a -7. And on the left-hand side, we have n is greater than or equal to 4 minus 6 is a -2. So I'm going to start with this one because that one is written in the correct form. N is less than or equal to -7. The second one, I'm going to have to rewrite. Starts off with -2 is less than or equal to n, but we need n to be in front, so we'll have n come in front. But the open section is facing towards the n, so it still needs to face towards the n. And now I can graph it correctly. So the two most important numbers on this is a -7 and a -2. Notice I'm not really counting where they're at, and that's okay. N is greater than or equal to -2. That greater than or equal to says we have a solid dot, and greater than means it's going towards the positive numbers. N is less than or equal to 7. Well, we still have a solid dot because of the equal to, but where it's getting smaller is going towards the more negative numbers. These are pointing away from each other, although they had less than symbols. So you know that less thans are interpreted as and compounds. So this is a no solution situation. No solution situation. Now, number 2, I need to alter it just a bit so that it'll work out for us. I'm going to make this one over here a 10x, all right, a 10x. Otherwise, it's not going to work out very well. And here we go. Now, this one's quite complicated, so I'm going to oops. All right, well, I don't know what's going on. But anyways, I do still want to make this one a 10x, a 10x. All right, so we need to rewrite these individually. So the first one is going to be from here over. So I'm going to write that down and quite large so we can stay focused. That would give us a 4x plus 10 is less than 17x minus 3. And then the second one still includes the 17x, but it goes to that direction. So our second one is 17x minus 3 is less than, and make sure you change that to a 10x like I did, 10x minus 19. All right, so this is quite a bit of math, so we will go ahead and get started. So let's see, we need to move our x's. So maybe we'll move our x's by subtracting 4x on both sides. Those x's are gone, and we're left with 10 is less than 17 minus 4 is 13x minus 3. So we need to get rid of the negative 3 by adding 3 to both sides. That's gone, and 10 and 3 is 13 less than 13x. Divide both sides by 13, divide by 13, and we have 1 is less than x. But remember, to graph this, we need to have the x in front. So we would rewrite this as x, then the open part, and 1. So this is the one that we're going to graph when we're done. All right, let's go work on the second part of this inequality. So let's see, I think we'll go ahead and subtract 10x. That'll give our x's on the right direction, on the right side. That goes away, and 17 minus 10x is 7x minus 3 is less than a negative 19. So we'll add 3 to both sides, add 3, and we have 7x is less than negative 19 plus 3 is a negative 16. Divide both sides by 7, and we have x is less than negative 16 sevenths. Now I find 16 sevenths a little hard to graph, so I'm going to go ahead and get me a mixed number out of this, and this would be x is less than negative 2 and 2 sevenths. That gives me a better idea of how to graph these two inequalities. So this is my second one I'll graph on the number line, and let's see what happens. So I have put one, oops, not the color. I'll put 1 right about here, and then negative 2 and 2 sevenths. I'll just throw on there. So x is greater than 1. Greater than is just an open dot, and it goes off to this side. X is less than negative 2 and 2 sevenths is also an open dot, but less than goes off to the left-hand side. So once again, these are facing away from each other. So this is another example of a no solution for an and inequality, because they both started off with our less than symbols, and that makes them an and inequality. And inequality. All right, let's look at 2 more and see what happens. So this one's quite lengthy as well. So we'll go ahead and write the first half to solve. 7 minus 19b is less than 7 plus 9b. And then the other half still includes the 7 plus 9b, and it's less than 18b minus 20. So those are our 2 problems that we will be solving. All right, let's see. I guess we can go ahead and subtract 9b on both sides. Those go away, negative 19 and negative 9. It gives us a negative 28b is less than 7. All right, we'll subtract 7 on both sides, and we end up with negative 28v is less than 7 minus 7 is 0. We're going to divide both sides by a negative 28. Divide both sides by a negative 28. And when you divide by a negative number, you got to switch the inequality sign. So this gives us V is greater than 0. So there's one inequality that we need to graph. Now we'll work on the other inequality. So let's see. I think maybe I'll subtract 9V on this side. So that goes away, and I've got 7 is less than 18 minus 9 is 9V minus 20. Add 20 to both sides, add 20 to both sides. That goes away, and 7 and 20 is 27 is less than 9V. Divide by 9, divide by 9, and that works out nicely. 27 divided by 9 is 3. But this one's not written in the correct direction, so we need the V to be in front. So V, the open part's towards the V, so it still is, and then the pointy part's towards the 3. So these are the two inequalities. These are the two inequalities we will graph. V is greater than 0 and V is greater than 3. So on a number line, we need 0 and we need 3. V is greater than 0, open dot, because it's not equal to, going towards the positive numbers. And V is greater than 3 is also an open dot, going towards the positive numbers. Now these would intersect. These would intersect. So the overlapping part is where V is greater than 0, because that's where they hook up and they continue to go into the positive direction. So that V is greater than 3 is where they intersect, and that's the solution part for this particular special and inequality. All right, the next one is also quite lengthy. We will rewrite these as two inequalities. And we've got 3x plus 14 is less than 4x minus 1. That's one of them. And the other one is this half. 4x minus 1 is less than or equal to 15 plus 8x. Starting with the first one, let's see, let's subtract 3x on both sides. Now we have 14 is less than 4 minus 3x is just x, and we still have that minus 1. So we'll add 1 to both sides, and we're left with just an x, and 14 and 1 is 15. But remember, we want the x in front, so we have to rewrite it as x, and the open part is towards the x, so we have to have the open part, and the pointy part's towards 15. So this is the one that we're going to on it. This is the inequality we're going to graph. Second side. Let's see. Let's go ahead and subtract 4x on this one. This is positive for a minute. That goes away, and I've got negative 1 is less than or equal to 15. 8x minus 4x leaves us with a positive 4x. Subtract 15 on both sides. Negative 1 minus 15 more is a negative 16 is less than or equal to 4x. Divide by 4, divide by 4. Negative 16 divided by 4 is a negative 4 less than or equal to x. Now once again, we want the x in front. So x, open part's towards the x, and it's equal to, and the pointy part is towards negative 4. So these are the two inequalities that we're going to graph. X is greater than or equal to negative 4, and x is greater than 15. So on your number line, you've got negative 4 way down here and positive 15 way up here. X is greater than 15, we'll have an open dot because it's not equal to, and greater than 15 is going that direction. x is greater than or equal to -4. So a solid dot on -4, and greater than is going to go all the way forever and ever. But this is another one of those that end up intersecting or overlapping at x is greater than 15. So the solution for this is x is greater than 15. All right. I'll go ahead and do two more last examples on these special inequalities. Number 5 is quite large again. The first half is -6n plus 15 is less than or equal to -7n minus 7. That's the first half. The second half is -7n minus 7 again is less than or equal to 2 minus 7n. So those are our two sides, our two inequalities that we need to graph and solve. All right, so we'll add 7n to both sides on the first one. Add 7n to both sides. -6 plus 7n leaves us with 1 positive n plus 15 is less than or equal to. N's go away, and we're left with -7. We'll subtract 7. Whoops, no, we'll subtract 15. Excuse me. We'll subtract 15 on both sides. That goes away, and I'm left with n is less than or equal to, and let's see, that looks like it gives us about a 22, a -22. And that's one that we will graph. And then on the right-hand side, let's see what we'll do here. Let's go ahead and add 7n to both sides. Add 7n to both sides. And our n's go away, and we've got -7 is less than or equal to 2, which is true, but we don't have any n's. So that's not very helpful. So this would be a no solution. There aren't any n's left in the second half of this inequality. No solution. Number 6 is pretty simple. I think we can do this in just one quick move. We've got to divide everything by a -3. We've got to divide everything by a -3. Now, the only interesting thing about this is that when we divide by a negative number, both of our inequalities have to change. So this one should go this way. And this one needs to also change its direction. So we've got x in the middle. -18 divided by -3 is a +6. So one of our inequalities is 6 is greater than x. And 0 divided by -3 is still 0. And our second one is x is greater than or equal to 0. Well, this one we need to write so that x is in front, and the pointy part is towards the x, and the open part's towards the 6. So let's graph this and see what happens. Our most important points are 0 and 6. So we've got x is greater than or equal to 0. So we've got a solid dot and going towards positive directions. And we have x is less than 6 going that way. And guess what? This is not a special case. This is a normal and. A normal and. And they are supposed to intersect in the middle. So just remember when you're doing this assignment that you do still have normal situations. They're not all special situations. So have good luck on 4.2, where there are some special cases, but there are some regular and situations.